You will see that this session is really, as the name suggests, is really designed to be an introductory session. So it's really going to start from scratch. First time from perfect? Okay, great then. It's really going to start from scratch and taking you through the basics. See, but now substance familiar with Python and Go, but I know it's very different because it's the compound like. Yes, indeed. Indeed, the fact that that you already know a language is something we'll come back on in a few minutes. It will actually help you. I've used it up to C++, but not used. Okay, that's different. Okay, I haven't split not too much. Okay. So mostly first time experience, which is good. Means there will be a lot you can learn in the next few sessions. So you will see that this session will be, as I will remind in a few minutes when we officially start. This session is really, again, as the name suggests, an introduction to C++. So it's really going to take you to the first steps. Okay, in this first session, we're not going to do anything very technical. We're going really to learn the basics. Compiling your program, running your first program, learning the basic blocks in C++. If you already have a programming language, which is one of the assumptions for this session, you will quickly find that you can map what you're going to be learned today to what you already learned in a different language, may it be C or Python or another programming language. They all share a certain set of features. Thank you, James, for putting the link. So you can go in the chat, you have the link for the materials, where you will find the slides that I'm about to share, as well as the exercises, which for this session are very, very short. 2 more minutes. Yeah, we can wait 2 more minutes. That's fine. Yeah, see, Matthias just joined. Yeah, let's wait a couple more minutes. Python and C. Okay, so if you come from the C background, then you come from a place with no abstractions or very little abstractions. And C++ is going to take you to that more abstracted way of programming. If you come from Python, you come from a place already benefiting from many abstractions. So C++ is going to take you to a slightly more controlled programming environment where we will see the rules about types, for example. Let me start, I'll drop now. Okay, sure. Sorry, I'm just replying to the moderators at the same time. Okay, well, it seems everything is in order, so I guess I can start now. Share application screen. Okay, can you all see my screen? Yes, okay, perfect. So as you can see, I just have a one screen setup right now, meaning that if I to make things simple, I'm just showing my screen and not a specific window, which means that when I'll come back on the chat, you'll have these wonderfully recursive visualizations, which are a bit not tech. But okay, so if you can all see that, great. So I take it the audio works, video works, and the screen sharing works. Okay, well, good to go. So I am Ludovic Capelli, I work at EPCC, and the slides we're going to use today are from my colleague Rupert Nash. Okay, so as I said a few minutes ago to the people in this session today, the first session is part of the ARCHER2 training and is a brief introduction to C++. So don't worry if you don't have a lot of experience in C++ or no experience at all. This is exactly what this session is designed for. Okay, so don't worry, we'll go through that together. It's going to be roughly an hour and a half session, maybe a bit less now. Again, the pace of this session should be very, very gentle. So if you feel like at some point I'm going too fast or there's something that I'm being confusing or vague about, don't be afraid to raise your hand, send a message so I can get the notification sound and I can come back and read your message. Okay? So C++, here we go. The starting point of this session is that somehow you know how to program on another language Again, some of you in the chat said, oh, I have experience with C, with Python. Good. Regardless where you're coming from, the fact that you already know how to program in a programming language will actually help you learn another language, because you will be able, as I mentioned a few minutes ago, you will be able to map, to draw links between the features you know and the features in C++. Some might not be directly mappable, let's say, but most will be. And it will just come down to a matter of syntax. Oh, how to declare an object in Python is with this syntax, in C++ it's with that syntax, but the underlying concept remains the same. Okay, so that will not be a big problem for you. It will actually be a strength to know something. You know how to use the shell, okay, so the terminal, and you have access to that terminal in front of you with a C++ compiler. So if you're on Linux, it's likely that you will have absolutely no problem, or Mac, to compile a C++ program. If you're on Windows, make sure that you have all your setup done with Visual Studio and any compiler you may want to use. We can't really help you if you're on Windows, because it's a bit more setup than just typing a command and having something being downloaded. Okay? This is not going to be about like super deep optimizations about something. Okay? The thing is, yeah, as it says here, writing efficient software more than anything requires you to choose an appropriate algorithmic approach for your problem. Okay? That is entirely true. Regardless of how well you optimize a given program, if the underlying algorithm is very inefficient, you will struggle to get a good performance anyway. But here, we're going to focus really on just teaching you how to implement certain things in C++. But again, for this session, it's the introduction part. Okay, so we will go very slowly. You will have more advanced sessions coming once this part is taken care of. So don't worry, we'll do things one step at a time. When it comes to scientific computing, generally what we always end up doing is when we run our program, there is a big amount of data modeling anything you want, whether it's for weather forecasting or for earthquake simulation. Somehow, somewhere, you will have a big amount of data to process. So you'll need to load your data, process it, and store it. Okay? Somehow this is always happening. In Fortran, that's a rather old programming language now. This is still relevant because Fortran forces you to deal with that all the time, very, very close to the action you're doing, by contrast to C++, which will allow you to create some abstractions from your computation. Okay? And composing them, when we compose things, is when we start to combine them, which we can do with abstractions more easily. So we're going to see a few of this. Let's check that I've not missed a message somewhere. Okay, it's just yes, fine. So here we're going to go a bit, when I mean here, I mean in the entirety of the trainings, you will learn techniques about C++. You will go a bit in depth for certain techniques on how to optimize certain aspects and how to use certain techniques. So it's really going to be for modern C++ usage, okay, and for the technical computing side of things. Don't worry, I am not going to teach you the entire language, i.e. everything in the language, for a simple reason is that modestly I don't know the entire language. Why? Because it's now a big programming language with 1,800 pages in the standard. So what defines what C++ does in which situation. And I will very happily admit I do not know the entirety of those 1,800 pages. The good news is it's rather unlikely you actually need all 1,800 pages to write something efficient and modern in C++. Okay? So the C++ standard 20, so the version for 2020, so C++ 20, that's 1,800 pages, and I don't think it's going to go down because more features get added. So you have many parts in C++ because it keeps growing and growing. In C++ 11, for example, so the version for 2012, there was the addition of lambda functions, for example, so more for the functional programming side of things. So you see, every now and then you have a new feature. Typically, it's every 3 years in C++, you have a new version. So C++ 11, C++ 14, C++ 17, 20, 23, and so on. And it has become a very complex piece of programming language. There's this way of seeing it, that this quote here that says C. So for those of you who know C, you know a bit about the different traps in C, especially when you deal with pointers and things like that. C makes it easy to shoot yourself in the foot. C++ makes it harder, but when you do, it blows your whole leg off. You will see what we mean by this maybe a bit later by your own experience. Another way to see it is C++ is an octopus made by nailing extra legs onto a dog. And what I like is the little comment at the bottom saying, but you can cut off some extra legs to get the right dog for your program. It's just that these are very flexible, so they offer you a wide range of techniques and features, so you have to tailor the ones you're going to use for your program. Let's come down to the bit more technical now. When it comes to C++, okay, it remains general purpose, okay? And as I said a bit earlier, it's about building abstractions, okay? And you will find that there is already a certain number of abstractions already provided to you through the library. What we mean by the library is the standard library, which we're going to use in the examples that are going to come. And there are, of course, many libraries that are provided as part of the standard set of libraries, and there are libraries that people build exactly like other programming languages, which you can then rely on for even further abstractions. I like this sentence, the one that says performance and efficiency are always targeted as you only pay for what you use, which means that you know exactly what's happening. Even when you're using abstractions, typically it will always use as little as possible, because it comes from this C mindset where it's about not hiding very much. C has very little abstractions for you, for those of you who know C. But the good news with this is that, as I said earlier in the last few slides, in C it's very easy to make a mistake. But the good point is that you really use very little resources when you do something because you're so close to bare metal. So C++ is higher from an abstraction point of view because of thanks to the abstractions we're going to see today. But at the same time, it preserved that philosophy of still minimizing what you actually use when you do something. So we're going to see that C++ is far from dead. As I said earlier, it's still expanding. Okay, I was mentioning, yeah, every 3 years, that's it. Every 3 years, a new version. So it started a while ago now. Okay, it didn't start just in 2020 or even 2011. Every 3 years, so the next one will be in 2026. So we have a few years to get ready for this one. The big change was C++ 11 with really this new lambda. It was really a bit of a disruption for classic C++ programming at the time. Anyway, so every time you have a new version, there are new features, which of course are always appreciated or not appreciated, but they are now available. And C++ 20 and 23 are no exception. If you ask me the exact list of features contained in each version, I'm afraid I cannot give you that, because again, these are very long lists, especially when you get into details. But you can check the changelog if you want. If you want to have additional reading about everything we're going to go through, plus more comprehensive documentation about C++, you do have many sources online, some of which are shown on this slide. Okay, so you can find the online reference, CPP reference, which is indeed very nice. Stack Overflow, which indirectly is very helpful because the questions you will have are very likely to be questions that someone else asked already a few years ago, and a question that has now been replied in a very proper, comprehensive way by someone already a few years ago. So it's all available and well indexed and everything. But if you want to have a bit more academic version of things, you can find programming principle and practice using C++. You know, the more meaty books, should I say. And same from Scott Mayer's, The Effective Modern C++ in 2014. And of course, the other one, Tour C++. All these are very valuable sources when it comes to a comprehensive knowledge of C++. You will see that depending on your needs, you may feel like you just need to know a bit, just enough to get your way through, to get a prototype done for a project that you will never touch again, or you may feel like C++ is actually bringing you the kind of benefits that you are looking for, and you may want to invest a bit more in it. And of course, the more you will invest, the deeper your knowledge in C++, the more you will be able to achieve with this language, and the more you'll be able to achieve efficiently. Again, it depends on how efficiently, on how important efficiently is for you. But before you go through hundreds of pages of documentations about very comprehensive C++ and so on, let's start with the basics, okay? So this is probably the smallest program you can do in C++, the good old Hello World, okay, which is a universal program. When you learn a programming language, you always have a Hello World program at some point. Well, at some point being as your first exercise, which simply consists in displaying the string Hello World, okay? So you've probably done that already in the programming language that you already know, C or Python, anything else. And C++ is no exception. So in C++, you see that this is how a program is built, okay? Composed rather than built, how it's written. So you can have your program, okay, in a file that we will call here hello.cpp, okay, CPP for C++. Yeah, the symbol plus is not very convenient to put in file names, so it becomes a P for plus. And to compile it, you use your C++ compiler, which in this case is G++, but you have other C++ compilers available, okay? The ones we're going to use here is G++ because it's free. You can download it on any machine, so it's fine. We say that with this part here, std C++11, std stands for standard. So we ask for the standard version 11 in case there is some feature, for example, that you would need for your program. Typically, C++11, as I mentioned a few minutes ago, was bringing so many major features, because that's also where we got C++ threads, I think, C++ multi-threading. Yeah, that it has become the default for many developers. So typically, when they compile a program, they by reflex put standard C++11, because you have all this large set of features that you now use as baseline. You don't assume you're going to lack these features in the C++ program. So that's why we do it. So that's the compilation phase, which people coming from interpreted languages such as Python may not be used to. So in C++, you have your source code, which you need to compile to produce an executable, which you will then execute. So how to execute it? This is how you do in a shell, which again, you're supposed to know. So do I have any message here? No, everything's fine. So if you don't know how to run a program, it's simple, just / and your program name, okay? Given, of course, that your executable is in the same directory as where you write and execute this command, okay? So the thing is, you see several parts. So the first line is what we call the preprocessor. So the preprocessor can be of multiple uses. Sorry, the one we see here is the include. Okay, so the include, again, you somehow have it already in the programming language you know. Maybe it's a different syntax. If you're from C, it's the same. If you're from Python, for example, you're more used to import and these kind of keywords, okay? And if you're from a different programming language that I've not even listed yet, you have them somehow, somewhere at the top of your program. Include or import are very likely to be one of the two. You're very likely to have seen one of the two already. So C++ is no different. We include the IO stream is the standard library for input and output, such as displaying text. So you just put in C++, the syntax is you put your library name between brackets, angle brackets. Okay, and that will search for that library in the system directories. Okay, nothing complex here. Do I still have everybody keeping up? The name of the output executable. Yes, that is this one here. Exactly. Did someone ask? Yes. So the O stands for output. So you say, oh, so by the way, I didn't receive a sound notification. Okay, that's going to be challenging. I'll just regularly check the collaborate session then. So yeah, the -O is for the output. So you select the output name, O for output. Okay. By default, if you don't pass this flag, it will typically call your executable a.out. Why? I don't know. That's the default name. So if you compile your program and you see that you don't have an executable called hello, check if you've put that flag, and if you haven't, you'll see that instead you have an executable called a.out in your directory, which will be exactly what your source code was compiled into, just with the default name. Okay? So now that you've seen, the second part is, again, like, I'm trying to find a programming language as an exception. I don't have one that comes to mind. Every program in C++ must have exactly one main function. There's a clear mapping in C. It's exactly the same thing. There's a clear mapping in Python, which I'm far less knowledgeable about. But I remember you do have this if-def program equals main. I forgot the actual main line. I'm not really a Python knowledgeable person, but I know it's in there. So if we have someone in Python, no, yes, exactly, Kevin. If you don't put it defaults to a or out. Yeah, that's it. So one main function, if you try to put two, it will complain. And the main function always has the same return type, an integer. To make it simple, you can go in the standard and check if whether changing the return type is still okay and so on. To simplify, always int main. The name of the main function is main. You can't assign a random name and say, oh, this is my main function. Your main function has to be called main. Okay? Yes, you see that between the parentheses here, we don't pass anything. Actually, we can have things passed, which are, as it says at the end, the command line arguments. Okay, if you want the full version, it's more int main, int argc, char, argv. But for the time being, introduction session, we don't have command line arguments. Okay, just int main, parenthesis, and we're done. Now comes the actual statement, the program. We have this first block here. So like in Python, I believe, yeah, JavaScript, same, yeah. So that's new for C people, for example, this notion of namespaces like that. So here you're going to say cout. So cout is what you need to actually print to the default output stream, understand the terminal. And you say, oh, cout from the std namespace. So std is the standard library namespace, which contains things such as cout, or at the end you can see ndl for end line, so to have a line break. So this says, okay, take the default stream to output data, so the terminal. Then we say, this is what I want you to output using this notation here, which technically, yes, it's called the bitwise left shift operator, or here we can just say double angle brackets. That's fine. Then we just pass the text we want to print, and then we just pass an extra bit of data, which is the actual end line. So if you want, you can pass for C programmers, for example, and probably Python as well. For C, definitely you can pass the /n, okay, like the line break, or /n and /r if you want to be complete. But otherwise, this is already contained in this constant here, available in the standard namespace. So namespace, colon, colon, and then your whatever it is you want to access. Okay? And you finish every single statement in C++ with a semicolon. Always. Okay? Unlike, yes, the last comment is important for Python programmers. In C++, there is no forced indentation. Spaces, tabs, line breaks, we don't mind. Which means that programs in C++ might have widely different aspects. They are all equally correct. Okay? So that will be a change for Python programmers. You have the freedom now to put 2 tabs or not to put no tabs, to put everything in a single line if you want, which can make your program much harder to read, but it's allowed. Okay? Everything's still fine for everybody? As I said in last week's session, in French we say qui ne dit mot consent, meaning that when people don't say anything, it means yes. So if nobody says anything, I take it everything is going well so far. Yeah, no question. That's fine. Okay. If there's any question, just post it in the chat, and hopefully we'll be able to catch up quickly. It's a bit of a shame that I still don't get that sound notification. No, I've not muted it. Okay, well, too bad. Anyway, so that's the first part. Okay, now it's your turn. So on your machine, you just need a C++ compiler that support at least C++ 11. Yes, you'll need certain C++ specific features soon. I don't think there's not any in this specific session, but when it will come to threads and features like this, you will need C++ 11. So that's why by default, just put, as we've said, --std equal standard equal C++ 11, and you're done. Okay. As I said earlier, if you're on Windows and use the Microsoft suite for compilation, for C++ compilation, it comes down to setting up your entire IDE and your entire software and everything. So we can't really help much, especially now live. But if you have access to Cirrus, which again you should have your log details by now, you can always connect on Cirrus and just with this command load the G++ compiler, which is included in the GCC module. Okay, so on Cirrus you have a list of modules, and you have one module containing the C++ compiler from GNU, so the G++. So you can just install it and load it just with this. Okay, so again, this should be pretty straightforward, especially if you're on Cirrus. And now the idea is for you to get the source code, compile it, run it, and if everything goes well, normally you should have this little lovely message, hello world, printed on your terminal. Okay, so you can find everything in this slide. You have all the links. I'm still going to give them again in the chat. I think James already posted the link earlier in this conversation, and I've seen the question. Lewis, I'll just come back in a second. Don't worry, I didn't miss your question. But in case it's not sufficient for the link, you have 2 links here. Okay, you can also find them on the ARCHER2 training page. So I think you have plenty of sources you can get those links from. Okay, so I'll just leave this here for a second in case you just want to copy and go old school. You have a few seconds to do so. And Lewis, so that's a good question. Is there a flag listing all the versions that a given C++ compiler can do? I must say I do not know. Is there a specific flag that would give us all the list of compilers? I don't know. It wouldn't sound unreasonable, but I don't know if there's a universal flag, or if it's more of a compiler specific. There are certain flags that are compiler specific, so G++ may have a given flag for something which the Intel C++ compiler wouldn't have, or would have with a different name, for example. And I don't know if it's something that would be available in old C++ compilers with the same name or with different names, or not available at all. I must say I don't know. Typically, you quickly know when something doesn't work because it tells you, I don't know this version. So if you type, for example, C++ 58, it will just say, I don't understand this. So you can quickly check. Again, unless you're looking for a very specific version or very specific feature that is available only in like 2020, in the 2020 version of the C++ standard, C++ 11 should have you covered. And now, as far as I know, they are all compliant with C++ 11. The challenge with these communities where there's a standard and then support in compilers is that they are not always instant. Because when the C++ standard, let's say in 2023, let's say it brings a new super important feature that is actually very hard to implement in compilers. This feature can allow you to do something amazing, but compilers have to be able to provide you this feature. So we need the people developing the compiler to actually implement the support for that feature, and that may take time. So that's why you have sometimes, typically more or less systematically, C++ compilers being not fully compliant to a given version because there's this tiny feature that maybe 1/10 of a percent of the user base will ever use one day. So they're like, maybe it's not a priority to do it absolutely now. So you can check the versions. Yes. What did I say? Anything different in Elena? STD C++ 11. Yeah. Yeah, man pages have a always very useful. It's a bit tricky when man pages start to diverge from -h, which is typically the universal flag to ask for help. Sometimes you find different information, which can be very tricky. When we do more advanced parallel programming, sometimes documentation starts to diverge, and it gets confusing. It gets a bit tricky. But okay, so if you found the information in the CPP reference, that's perfect. Again, that's why we give this website as one of the main references. It's because they have a very comprehensive documentation when it comes to C++. Okay. So now you should all have this, so you can use the editor you want, whether you want to go for terminal-based text editing with Vim or Emacs or Nano or anything else you want to use, or you may go for with IDEs, Visual Studio, and everything else. Just compile a program. You have the compilation command here, and you run it. And normally you have your program. So you will have the hello world message printed. So where are we up to? Does anyone have reached that phase already? Yes, okay, no problem. No panic message such as I've got a very ugly error message of 15 lines or something. So it seems it's going well. Okay. Yes, as it says also in this slide, no output means success. So you will not have a confirmation message saying, oh, your compilation went well and we successfully compiled your program. C++ will only say something when things go sideways. So no output is a good news. Hello. So Kevin managed to get the output directly in the chat. Let's say it was some redirection and everything. So that's actually something you could do with the redirections in C++. Anyway, now a few more things. So I take it everybody now had a chance to run the program and get the corresponding output. Nobody's lost about the basics we've just covered about a simple Hello World program. Everything's fine. I think everything's going well so far. Again, don't worry if you feel like this is way too easy. I promised at first that we would start from scratch. So we do start from scratch. If you have a level that is beyond that, don't worry. Soon enough, you will have something that is new to you. Okay, maybe this session will be a bit easier for you, a bit easy for you. When we will come down to multi-threading in C++ and things like that, and container loops, iterators, maybe you will start to learn a few new things. So try to keep up. I promise we'll have something new soon enough. But here, back to the introductory content, a few more things. We say, it is said that C++ is a typed language. Okay, variables must be declared. You can, that's something new. For example, that's a C++ 11 feature. You can often tell a compiler to figure out the type. So in Python, for example, you don't have to give the type of a variable. Just say my variable, and you give the value 15, and Python understands that this is a number, somehow an integer. In C++, let's say until C++ 11, you had no other choice but to clearly say this is an int. In C++, we have the auto keyword, which you will learn about again in a I don't know if it's next session or in 2 sessions, you will see it again, where you tell the compiler, okay, I trust you, figure it out. If the compiler cannot deduce the type of a variable, it will tell you. It will simply say, okay, I cannot deduce the type of this. Please tell me what it actually is. Most of the time, though, it's able to deduce everything. Yes, this is a very sneaky difference. If we have any Fortran programmer, do we have any Fortran programmer in the audience, by the way? Yes, we do. Perfect. Welcome. So, yes, I've lost sound. Will even yes, absolutely no problem. So you will see that you know that in Fortran, or if you're not in Fortran, if you're not a Fortran programmer, in Fortran the indexes start at 1. In C, C++, Python, they start from 0. This is a wonderful way to be sneaky bugs in your program, just having that index wrong. So yeah, be careful. In Fortran, it starts from 1. In C, C++, Python, it starts from 0. So today we're focusing on C++, so in C++ it starts from 0. Again, very sneaky, but especially if you are going to switch between Fortran and C++ code on a regular basis, because you have a big project in Fortran and you're now working on a prototype in C++, switching from a program to the next requires that mindset, that mind gymnastics, which can be very challenging at times. So if you have a bug at some point in C++, if you're coming from Fortran, check your indexes. Okay? Everything's fine with the indexes trap? Okay. Now the thing is, I'm late. I'm very late. 1 hand raised. Okay. Has the person who raised their hand got their question answered? Because I've been rather quick. So we have time. Don't worry. If you have a question, we can take the time to answer it. Oh, it seems it's fine. Okay. Okay, well then I will resume. Oh yeah, if we want the Hello World script, do we have to compile? Yes. So the source code, in our case, it's not a script anymore. The source code of the Hello World program, every time you modify your source code, you will have to recompile. Okay, the same command, yes, because the file that you are compiling still has the same name. The output name for your executable is still the same, and nothing changed in the compiler you used. Your screen share seems to have gone blank. Is it just me? Oh, is it okay now if I do this? Same here. Oh, okay. So the screen sharing got down. Okay, let's somehow stop it and redo it. Okay. Is it back now? Can you see the wonderfully recursive, hypnotic? Okay, great. Yeah, sorry, it's that's interesting. On my screen, it didn't say that the screen sharing stopped. I was actually still being told that I was screen sharing. I was sharing my screen. So okay, thank you for telling me. Again, if there's anything going wrong, you tell me and we fix it. So okay, so everybody had lost. Okay, that's an interesting one. Anyhow, any question, anything else? So did you manage to recompile your program, Amna? Okay, yeah, Zeki, that's weird. I didn't try. Okay, you will have plenty of time to try later. That will be a very quick update anyway. But yes, yeah, that's a good one. Every time you modify your program, if you do not recompile it, your executable is not updated. Because unlike Python, where you pass directly your files, your scripts, and they are interpreted, here what you execute is not the source code, it's the binary that you produced from your source code. So if the binary has not been regenerated by an additional compilation, then it's not up to date. So yeah, for Python programmers and for programmers coming from interpreted languages, remember to recompile every time. Okay, if that's fine for you, we can move to variables. No questions, I believe. No, it's fine. Okay. Hopefully, I will not lose my screen sharing again.
Oh, sorry.
So variables
type. Sorry.
Variable is an object or a reference. They can have a type and a name. I don't think this will really be of groundbreaking importance to you. I mean, you probably expect this. Maybe Python programmers having a type, or maybe JavaScript, for example. Here we give a type. Okay, I don't think that there's a programming language when we can declare a variable without a name. That would be interesting. A bit useless, but interesting. So objects. So objects have a type. Okay, integer, floating point, string, character, class of something. A size, okay, the amount of memory they take in memory. The value that they contain, a number if it's an integer, the actual string of characters if it's a string, and so on. And the lifetime, the fact that an object may go out of scope, for example. This is something you can see. I don't know if it's in next session, maybe. Let me check this. No, still a question. Okay, perfect. So when it comes to types, like all typed languages, there are a few built-in types. Okay, and C++ is no exception. Yes, first let's go through the definition. Again, look at the source CPP reference. Okay, so if you need something, the information is somewhere on the CPP reference website. So just for everybody to hear it, objects and expressions have a property called type, which both restricts the operations that are permitted for those entities and provides semantics meaning to the otherwise generic sequences of bits. Sorry. What does that mean? Number one, let's start with the last part. Provides a semantic meaning to the otherwise generic sequences of bits. The following sequence of bits, 1 0 0 0 0 0 1. If I ask you, what is this? We may have a few people in the audience say, oh, that's 129. Or that's -1, depending how you encode it. Or that's something else. It might actually be a letter, or it might be a number, or it might be a picture. The thing is, the type indicates how to interpret a given list of bits. Okay, a given sequence of bits. That's the second part of that quote. The first part is when you're going somehow to interact with that sequence of bits, the type is going to tell you how to actually interact with it. Normally, it's not something you do manually, okay? But it indicates behind the scenes to the compiler, okay, that's a number. That's a number. If I ask you to add those two numbers, you use a sum. Then if I ask you to add two strings, does it mean that I take the first letter and the second letter and I add their value together, or do I concatenate the two strings, which is very likely to be what we mean when we want to add two strings? But you see, that's what the types are for. Oh, little question here. I can really, yes. If your program doesn't change in this case. So the question from Elijah was that if his program is, sorry, I cannot tell, I don't want to assume anything. So if Elijah's program reads data from files, can it run it without recompiling, even if something is changed in the file the data is read from? In this case, you don't need to recompile your program. Why? Because the actual binary, which you obtain from the compilation of your source code, is left unchanged. Inside the binary, the comments that it contains is still read from the file called myfile.txt and print whatever it is you read in it. So this is fine. You can update the file myfile.txt without having to touch the binary. However, if in the binary, so if in your source code initially you said that you're going to read from a file called myfile.txt and you compile that, this binary now will expect to read, oh sorry, I was outside the screen, will expect to read from a file called myfile.txt. So you can change the content of that file, it's fine, but if you change the name of that file, then you need to update your binary, because in your binary, it will still try to look at a file called myfile.txt. So you will need to update your source code, recompile it to obtain a new binary that will go and fetch the right file with the new name. Make sense?
Yeah, thank you. Thank you.
Okay, makes all sense. Good. Get back onto the types and the types provided. So there are fundamental types or built-in types. You can see them the way you want. There's one that is a bit daunting at first, which is void, which represents no type. So it's used in C and C++ to indicate that a function does not return anything. Okay. So depending where you're coming from, you may understand functions as routines that do return something, by contrast to procedures. In C, there's no such difference between a function and a procedure. Everything is a function. And if a function happens to return nothing, we just say that it returns void. Okay? That's how it's done. In C++, like in C, a function cannot return more than one value. Okay, so if your boolean, if your function returns a boolean, then it returns a boolean. It does not return a boolean and then return an integer and then 3 strings. It returns one thing, which can be of a compound type, containing maybe an integer and 2 strings and a boolean. But that will be, you will have encapsulated all that in a single type you will have called, I don't know, my super type, and you will say this function returns this, but it does not return multiple things, it returns one type. So the boolean you probably already know, regardless where you're coming from, which programming language you come from, true or false. Okay, simple. The integer, that's where options start to arrive. By default, the standard integer is assigned. Okay, So it can have positive values or negative values. The C++ standard says that an int, so the default standard integer, is at least 16 bytes, okay? But behind the scenes, realistically, it's extremely likely to be 32 bits. Did I say 16 bytes? 16 bits, 2 bytes, 16 bits. But in practice, it's likely to be 32 bits, so 4 bytes. Okay, that's the size of an integer these days. Even if, again, if a compiler uses 2 bytes to store an integer, it is perfectly compliant with the standard. Okay, it's not a rule for integers to be 4 bytes. It's just for some reasons behind the scenes, it's more convenient. You also have floating point floating point types. Okay, so we have float, which is not shown here. Here it's shown double, which is double precision floating point. So with a floating point, there's so much precision you can get. So if you want to get even more precision, you use a double precision floating point, double keyword. Okay, and if you want to go raw, you can go std byte, which is untapped memory. Again, usually you're unlikely to use this one unless you use it for a very specific purpose. But for an introductory session on C++, integer double, that should be enough. So you also have unsigned versions of integer. So int has an unsigned version of int that's called unsigned int. Okay, you just prepend the word unsigned. There are, when it comes to integers, there are many different versions. You can even have fixed width types. So for example, if you need to have a 4-byte integer, you know that if you just type int, usually it's 32 bits, it's 4 bytes anyway. But there's no, again, as I said earlier, there's no hard rule saying it has to be 4 bytes. The rule is it has to be at least 2. So if it's 2, it's fine. If it's 4, it's fine. If it's 54, it's fine as well. Okay, so if you are asking for a very specific integer to be 4 bytes, we have this option in C++ to say in the corresponding header. So you've seen IOStream when we displayed text in the first example. Now you see cstdint. So let's break this down. std for standard, int for integers, and c to say that it comes from the C header called stdint.h. But in C++, we replace .h with the C when they come from the C libraries. Okay, so you can ask for a 4-byte integer, std, so the namespace std, and in that namespace, find this type, 4-byte integer, or if you need an 8-byte integer. Okay, make sense? No question. Again, things are rather simple. They make sense. They're intuitive so far. So nothing groundbreaking. Okay, it makes sense. Perfect. And of course, as all programming languages, we also have strings. And to have strings available in your program, you simply need to call, again, one of these preprocessor macros, the string header. Again, simple string, nothing else. Hashtag include angle bracket, the name, angle bracket, done. Okay, and then you can use std string in your program. Why? Because string comes from the standard namespace, so std : string. And then you can start manipulating strings like you normally would in other programming languages. And now you know as well how to display it by using these double angle brackets. So now you need nothing else to actually do all that by yourself. Finally, all good so far. Perfect. So everything's fine on that part for the strings? Again, I'm checking every now and then because number one, we have 35 more minutes. So I think we'll have extra time at the end. So it means we can really slow down if something that I explained I wasn't clear, for example, I didn't explain well, I can always try to explain a different way. And number two, because this is the introductory session, meaning that everything we learn here is going to be the fundamental block for every other single session. All the other sessions will rely on everything that has been shown here. So again, what we learn in this session is easy, but if there's something that you don't understand, it's the perfect moment to get. Are strings mutable? Yes. So mutable means when you assign a string, a value to a string, can you change it afterwards? Yes. If you want to make something immutable, in C++, you can use the keyword const. So for example, if I type const and then the rest, string, message, hello world, I will not be able to modify that variable anymore. But that you will see in another lecture about constness and these. So yeah, by default they are, and you can make them not if you want. So either way, you're covered. So then, if no more questions, I think we can move to the functions. Okay, nothing else still? Okay, function it is. Functions. So the way functions work in C++ is identical to C, except for one thing we're going to see next slide. But for this slide, it's the same. Same as Python, you just have a return type. So void means you don't return anything. Okay, so you see there's no return type here. Technically, there should be a return type here for the main. So your main function, normally, the value that it returns, you may actually wonder why we even return a value from the main function, because that will be the function that will be called to actually launch our program. So it will be the first function called. So anything we return from that function, we won't be able to use it in our program anyway. So why do we even want to return a value? Typically, this value tells whoever executed that program whether things went well or not. There is a common practice to return the value 0 where everything goes well, and to return another value when things go wrong, typically a negative value. So what you can do is, in your program, you do your say hello, okay, which all these functions here, which simply displays the text to the default output stream, i.e. the terminal. And after that, typically you would say return 0 to say my program run without errors, okay? But if at some point in the program somewhere you find an error, or you have an exception, or you have something else, you may return the value -1 or -14, because your program, for example, in the documentation provided with your program, you say, if it's the value, we were talking about files, for example, when you say, oh, if I modify the file, and I give also the example of changing the file name, you may have a program that reads everything from a file called, again, myfile.txt. It reads everything, prints everything, and returns 0 if there was no problem. But it may so happen that the file doesn't exist because the name is wrong, or because the location is wrong. Maybe the file now has been moved to the desktop or to your picture folder. So you may want your program to say, oh, if it does not exist, if I didn't find the file, then I will return -1 from the main function instead of returning 0. And then you say in your documentation for your program, if I return 0, it means everything is fine. If I return -1, it means I didn't find the file. So then the user can check the value. When you execute something in the shell, any command, you can check. So which one is it? You can check the actual value that has been returned by the command you just executed. Launched. I don't know if it's $! Or $0. Would be interesting to find I don't remember. I've not used that in a while. But every program you run returns a value that you can check for the use. Okay. So the function, let's come back to functions. These functions say hello, doesn't return anything, void. You have the name of the function, and then between parentheses, potential arguments. If no arguments, you just pass nothing. You can even, that's more advanced. You just pass nothing. Okay, and then you have the actual body of your function between curly brackets, always. And you can see that the main function is no different. There's no exception, sorry. The return type int, the name of the function, the different arguments separated by commas, okay, and curly bracket for the body of the function. Yes, this is the other version to write the main function. The one we showed in the first time was int main and then parenthesis with nothing in it, which is allowed. The other one is the one where you use the command line arguments. And if you ever want to get access to the command line arguments, this is how you have to declare your function. Okay, so I won't go into the details of this yet, but this is how you can get access to the command line functions. So our functions always void because the output is a string. How well that is. So this function typically will always be a void yes, because it does not produce any value. You may transform this function. Actually, it might be the final exercise. So let's try to take another example. You may want this function, say hello, to do two things. Number one, to actually print that string, and in the second phase, sorry, return the actual message that it printed as a string. So that this function, when you call it, it prints the value, okay, so hello world, but it also at the end returns that string, so you can do something with it. In which case you would say that it's no longer void, but std : string. Okay. Yes. So if you have a function, for example, let's say that let's reuse the function main here. Let's say we create another function that just takes two numbers and sums them up. So you would have just integers. We just deal with ints here. So you would have a function that takes two integers, calculates the sum, and returns this value. Okay, so you would declare the return type of your new function to be int. You're going to return an integer. Okay, and the name of your function, sum, my sum, add two numbers, the name you want. And then you just pass two arguments. The first one being an integer that you can call a, type of the second argument, another integer, so int again, and the name of the second argument, b. And inside your function, you would do return a plus b. Okay? So you can easily return anything you want. But again, one type for return and one value return. You can't return A and B and C and no. You can return one thing. I emphasize this because, again, depending where you're coming from, it's very convenient to have multiple values returned at once. But in C++, we can't do that. Any other questions on the functions? Now everything seems to be fine so far? This one? Okay, so thanks for the update. So in the shell, when you're looking for the error code, so the value returned by your program, by the last comment you execute it, it's $! Okay. So with this, you can then find the value. So if your program in your main function returns 0, this is how you will see it. Okay. Because remember that your program might be called at some point by a totally different program, which may want to check if your program completed successfully or had an error somehow. So this is by these return values that we tend to communicate in C++ to check for correctness, to check for, well, to get the actual value that a certain function needs to produce, such as the sum of two numbers or something. Okay, so if that part is fine, then we can move to the slightly more challenging aspect of functions. Oh, actually, okay, I gave you this example directly. Okay, well, perfect. The integer sum. So that's the example I gave you. Okay, the one I gave you like virtually. Now you can see the code. So as I said, the return type first, you return an int, the name of your function, and then different arguments separated by commas. Each argument is made of a type and the name, as always. So argument 1, which is an integer called a, argument b, second argument, which is an integer called b, and you return the sum of the two integers. And the type of each variable indicated how this operator here is going to behave. When we have two integers and we put a plus between them, we know it's the sum, the arithmetic sum of them. If it was two strings, maybe it would be something else, but we're going to see that in a second. There's another notation which is far less common from experience, which is this one. Again, as far as I know, I don't think I've actually seen the code using it. No question, no yes. But technically, it's still available if it's really something you like, because it's closer to your existing programming language knowledge. That's fine. But typically in C++, we'll tend to declare everything like that. No, that was fine. Yes, I think this one is very easy. Regardless where you come from, you always know how to pass the arguments. So in C++, you have the name of the function, parenthesis, and then again all the arguments that you want to pass to that function, separated with commas. Okay. And of course, yeah, okay, no question still, okay. Of course, as it says at the end, they have to match the declaration. In other words, if you say that your function sum declared here, it receives two integers and you try to send an integer and a string, it will complain. There will no be, there might be some implicit conversion of types, but it's not automatic. If I pass a string and you expect an integer, how can I convert it directly? If you were asking for a 4-byte integer and I pass you a 2-byte integer, that's very easy to cast. Okay, the variable I contain will contain 65,000 possible values. The one you expect contains 4 billion possible values. Well, mine is clearly encodable in yours, so that's very easy. But if it's a string I pass and you expect an integer, how do I convert it? I can't. So it will just say, I refuse to compile. I don't know how to convert this. Okay. Fine. And now the fun part, function overloading. So for C programmers, in Fortran, I don't think that's available either. In C++, you can overload functions. So it means that you can have multiple functions. Okay, I have the same name but different arguments. Because the thing is, so the signature in C, the signature of a function is just the name. So as soon as, for C programmers, as soon as you have a function, that function has a name, it's identified just with its name. So you cannot create another function with the same name. Okay, In C++, the signature of a function, what allows us to identify a function, also includes the return type, another return type actually, the arguments. It contains the name and the arguments, meaning that you can perfectly reuse the same function, well, a function with the same name and different arguments, which is what we call function overloading. So you can have a sum that accepts two integers and returns an integer, and the same name for a function that accepts two doubles and returns a double. This is perfectly allowed. And then when you will call that function sum, the compiler will deduce which version you're actually calling. So if you pass two integers, it will know that you're calling the first version. If you pass two doubles, it will know that you're calling the second version. Okay, and now the thing is, as it says at the bottom of the slide, which is something I mentioned a few seconds ago, if something doesn't fit, the compiler will try to convert the types you're passing for you. If it can't, it will complain. If it can, it will not say anything and will directly pass them. You can form user perspective. Interesting. You can form a user perspective via an interface statement. You can form a user perspective via an interface statement. Oh, sorry. Fortran. I missed the context. You can have Okay, so in Fortran, it seems we can't have the same name in the same way in Fortran. Okay, well we have Fortran programmers having the discussion. I must say I won't be able really to keep up with Fortran. I'm really a C++, and more of a C person. Fortran, I'm not sure I can keep up. So Kevin seems to be more knowledgeable than me. So Kevin and Lewis, I'll let you two have these technical Fortran discussion. I'll keep an eye on the outcome though. And then we have this question from Kostas. What if two functions have the same number of arguments? Does it still work? Yes. If they have different argument types, yes. They can, well, like these. Actually, they have the same number of arguments. They each have two arguments. So they are perfectly allowed to have the same number of arguments. There will have to be one difference at some point in one of the arguments for you to be able to have multiple times the function with the same name. So you can even create another sum function which has an integer a and a double b. That is not redundant with any argument list here, so it's fine. And you can have the opposite. You can create a fourth version of that function, which would take a double a and an integer b. And then somehow in your function body, you would do the calculation of how to add a double and an integer together. But that's perfectly allowed. So it still works, yes. Function overloading, any question about it? That for C programmers can be a bit daunting. For Python, is there function overloading in Python? I would think so, but I'm not sure. Python programmers, your time to shine. Is there function overloading in Python? No. Ah, okay, sadness. Okay. Usually Python is always much friendlier than C, so I expected, since we don't have it in C, I expected Python to say, of course we do. Not like this. Okay. So you have a way to somehow overload it, yeah. But not the, okay. Okay. Any other question on the function overloading? Because after that, yeah. Well, yeah. The challenge with function overloading, still no question, it seems, okay, right? Is that it's very hard at the end to know what's happening. When we have two numbers, we know it's a sum, okay? Integer 1, integer 2. So when we pass two integers, we know that it calls, we know that it calls this function here, integer 1, integer 2. When it's two actual literals, in this case constants, so again, we'll call this function here, the first one. When it's two doubles, see D1 here, D2 there, when it's two doubles, again, we know that it's going to find immediately this one. But now what happens when we start mixing things, such as, that's fine, that's 2 doubles anyway, a double and an integer. How does that work? It will say, well, I don't have anything that starts with a double and finishes with an integer, so I don't know which function you want me to call. So either you will have to somehow convert the double to an integer or the integer to a double so that it can find its way back to one of the functions you declared, or you will have to create an additional function that will take a double and an int. Okay, both ways are doable. I see there's something. Actually, you can overload the variant. Okay, that's Python. So if we have two functions with the same name but different return type, I can't have the same argument number, name, and type. Yet, if there is no variation in the name and there is no variation in the arguments, these functions are seen as identical. So if you try to create a function, let's say here, you have a function sum that takes 2 integers and returns an int, and you try to create another function called sum, which also takes 2 integers but would somehow return a double. That's not possible, because it will say there's already a function somewhere that is called sum and that receives 2 integers. So you need to change either the name or the argument list to be able to do something like overloading. So changing the return type alone is not sufficient. And that means something of the form I let you have this discussion. That's interesting to see where things are going. Nice. And for something like a name and a file, what does it mean to sum a name and a file? You can see it in many ways. Probably the most intuitive would be to append a name to a file content. Or does it mean actually adding the string name to the content of the string file? So file, for example, is a string that contains the value data.csv, and name is a string that contains the string Alice. So if we are just concatenating strings, then the string that this would produce in this line here would be data.csv Alice. Okay, but maybe what you actually mean when you want to add a name to a file is to actually open the file and store that extra name in the file and then close the file, which you can perfectly do in C++. But you see, it's when you start overloading functions, it can become a bit tricky to know what is actually being done in the behind the scenes if it's not properly documented. Because in this case, both approaches could be fine. You could argue that no, of course, when we take 2 strings and we add them together, it just means string 1, string 2, we concatenate. But as a human, if you see a name and a file, you may assume that it means opening the file, putting the name in, and closing the file. But maybe for the program, it's not how it was defined. It just means concatenating strings. So you can also do something with overloading, which is great fun. It's when you start overloading operators. That's something we can't do in C. I really like that part of C++. Overloading operators is really fun, because then you can reuse the same notation as you would use, for example, for this return here, A plus B, okay? But you can create an operator that says, oh, if it's 2 strings, you have string 1 plus string 2, that operator will return something that is actually a string containing both strings concatenated. So you can do that in the operator directly. As I said, I really like this. So this means, okay, I want to overload an operator. So you have to put the keyword operator. Which operator are you going to overload? The plus operator. Okay. It's going to take a string called A. Don't worry about the const and this symbol here. You will learn this a bit later. Next session, I guess. So a string A, comma, for the separation, and another string B, okay, and this function, because it's nothing else than a function, it has a special name because it's the operator plus, but it's still a function, and it will return a string. Okay, so that's one way to do it. And as soon as you have defined that operator, you can use it. So you can do things like that. Having a string, you see, username, and passing another string, the compiler will understand that this time you have a string and another string, and you want to call that with the operator plus. So it will find this declaration here, and it will execute the code contained in that function. Okay, make sense? It seems so. So far, it seems to make sense. Doesn't compute with a mathematical operator. No, because it's just the mathematical operator, if you want, is defined like that. It's defined in C++ by default. It's defined for, let's say, 2 integers and returns an int. It's defined for 2 doubles and returns a double. But it's not defined between strings. The notion of mathematical operator in C++ does not mean anything. In C++, there's a function which is plus, and it can take 2 integers, it can take 2 doubles, it can take a double integer, it can take many things. So if you add one more function with the same name, but different elements, different argument lists, different types, then C++ is fine. It's just says, okay, that's one more overloading of this function, which happens to be an operator. Do you still have to define? Do you still have to define how to combine 2 strings? Yes. This line here just declares a function that takes 2 arguments of type string and returns a string. But what it actually does with these 2 arguments is something you have to define. You can do everything with it. You can even not do anything if you want. It's not because it's plus that it has to somehow return a concatenation. You define what it means to add 2 strings together. You will be the one defining what it actually means behind the scenes. Where this operator function should be defined in the string class. You can, but typically you can declare it globally. Okay, you can declare it up. Where's the main? Yes, here you see just the way we declare this function. You can declare your operator function. So you can put std string operator plus the argument list, and then put curly brackets, put your actual code inside of what it is you want to do with 2 strings, and then close it. You can put it in this example right here if you want. And so I guess I answered the question. In the last 5 minutes, there's this little exercise. I just want to mention it. If you want, we can have. I can still answer more questions, but just to give you this exercise, which you can find with the links that were shown earlier. So in this one, yeah. In this one, the idea is this program here reads a name from terminal, okay, and then it prints hello. But so far, it just prints the string hello world, and we would like it to print hello world to you or to whatever it is the name has been entered by the user. Okay, so I'm Ludovic, so if I type my name is Ludovic, I want the program to say hello world Ludovic or hello Ludovic or something. Okay, so somehow you need to insert in this statement here the name that has been given by the user, which is here. So you see that the way we call say hello is we pass a string, okay, name, which is a string, but it's not received here because we didn't declare a string to be received as the argument. So you will have to update this, and you also have to update somehow this statement to include the extra string, the name of the user that you now want to print along the header world. So I let you work on this. In the meantime, no new function, okay? Elena, have I replied your question? In the meantime, I'll leave that here for a few seconds.
Yes, I just tried to do that, but it doesn't work still. But I think that I have, yeah, that we have other problems in this example. that
we just got over 100
still...
messages in chat. Okay. 101 messages. Very collaborative environment. This is great. So is there, can you hear Elena talking? No, I can't actually. So it seems my speaker volume is at 100%, as you can see. I'm not muted, am I? That's right now. That just means I'm sharing my screen.
Can you hear anything at all?
The camera, use voice, audio settings. No, that should be enough. So I can't hear anything from that. Yeah, I'm definitely not mute. That's fine. That's fine. Okay, so since I apparently cannot hear. Okay, so I can't hear anything. My apologies. Which means that it may have happened that someone during this session talked, and I, of course, totally ignored that person. My apologies. Of course, it's a total accident. I just cannot hear anything. I could hear when James talked, so I assume that my audio was set up properly. But somehow along the way, at some point, I lost the ability to hear, which is ironical since I already have hearing problems in real life. Okay, it seems that my computer now does too. Okay, well, so if there's any question that someone asked or any comment that someone spoke and I didn't hear, my apologies. Please feel free to write it again, and I will very happily reply to it. Are there any problems with the reusable plus example? She may have some additional problems with the overloaded plus example. Okay, we'll be interesting to see what kind of problems. If it's not already defined, a plus with strings, then you won't have any problem. Error code, sometimes it's ambiguous. So the thing is, okay, so there is some conversion behind the scenes. Okay, so I can reply to this one because that's a very tricky one indeed. So here, so what you did was to create a sum or plus, okay, plus. So the way it works in C++ is you already have some very ambiguous. Yeah, the thing is, behind the scenes, it tries to convert a double to an integer directly. It tries. So if you expect a double, it will try to convert your integers double and vice versa. So the thing is, when you have, let's say that I create another version of this first sum signature. So I create another version of the sum that takes a double and an integer. Okay. So I have a version that takes two integers and a version that takes a double and an integer, which I guess is what you've done, maybe. The thing is, the C++ compiler, if you pass a double and an int, or actually no, actually it's in this case here. If you pass one double and one int, it doesn't know if it has to convert the double to an int and then call the first version, or convert your int to a double and call the second version. So that's why at times you may need to help the C++ compiler say, oh no, okay, convert these double into an int, and then pass this newly cast int with this int and call the corresponding sum function. Okay, yeah, I think which example you mean? This one here? Yeah. If it's this one, then it's meant to fail. Well, fail. This one doesn't fail, just doesn't do anything with it. This one, I wasn't expecting this one to actually. Yeah, it fails if you use something that is hybrid. But if you call sum with 2 integers, it's fine. If you call sum with 2 doubles, it's fine. It's just that if you start mixing things, then the compiler cannot distinguish which one you actually want to use. Because I think we're not expected sum.cpp. Okay. Yes, it's already half past, so I'm afraid we have to stop here. You need to have a break before the next session, so please go have that break. So I define function in installable. If you want to be comprehensive, yes. If you want to not rely on any implicit cast, you may want to do that yourself, yes. Because again, you may have a somehow very unusual function that if it takes a double and an int, does something with it, but if it's an int and a double, does something totally different. So it might, that's the trouble with operator. Yes, when you start playing with operator overloading, then you have a whole new level of freedom, but you make potentially the compiler's life a bit harder because it's going to have multiple choices when you will have to cast something. When it doesn't find a direct mapping, it will have to find a way to somehow cast one of the arguments to make it work with one of the potential function signatures available. So if there's more than one choice available, the compiler says, I don't know which one I'm supposed to do. You didn't give me an explicit direction, so I tried to convert something behind the scenes implicitly, but I now have more than one function that could match. If I cast this one to an integer, I have this. If I cast this one to a double, I have that. Which one am I supposed to use? So when you're in this position, you just explicitly say, cast this to an int, okay, and now pass these values to the function. That you will learn how to do. We'll come on and do it to remove the need to recall. Yes, you will learn that later this week. You will learn many more things. But again, this was the introductory session, which has now come to an end. So thank you for your time. Go enjoy your well-deserved break. Feel free to play with the examples you've seen. Again, in the slides, you have everything you need. If you have any questions, feel free to ask them and we'll be very happy to reply. Otherwise, time for me to wish you a good day and see you tomorrow. Bye.
Okay, good afternoon. Can everybody hear me? If so, can somebody just let me know? Great.
Yes, I can hear. Yeah.
Fantastic. Thank you. Okay, so this morning, earlier this afternoon, we covered the introduction to C++. This afternoon, we're going to talk about classes, which are fairly fundamental to C++. From the perspective it's an object-oriented programming language, but also because we can use them to define new types for our applications. So in C++, we can define a class or a struct. We can define a class using a struct or class keyword. Here we see that we're actually using the struct keyword in the same way as we would do in C, and we've got two fields here, two member fields as we'll refer to them, member variables. I don't know if it was mentioned in the last session, but the compiler explorer on Godbolt is really good for looking at some of this stuff. And the example here, if you click on it, you'll actually see it in the compiler explorer. It's actually really good. You can generate code for a number of different processors and using a number of different versions of the compiler, whether it's Clang or GCC, and different versions of each one of those. So you can see what actually happens there and what happens when you change the actual flags, the compiler flags. So as I said, this struct complex here is what we call a plain old data type or a trivial type. It's very similar to what we would see in straight C. And it basically just collects a number of members together. under a particular type, so you can pass them around and access the data. So we can create the trivial types, and as we see here, when we're creating them, what we can do is we can list the values to be assigned to the members in order inside braces. So this make imaginary unit function is going to return as a new complex number, and you initialize it with inside those braces with 0 and 1. And we call this aggregate initialization. Alternatively, we can actually do it more explicitly. So in the second alternative here below, we can declare the variable. It's square root underscore m1 there as a complex. It's uninitialized, and then we can then initialize the actual member variables individually, as we see here, square root underscore m1.re and square root underscore m1.im, and then return that initialized complex number. You may have seen this in the actual function definitions here. I've got void for the parameters. That's a convention whereby if there are no parameters, you can either leave it empty, so you could have open bracket, close bracket, but by putting void in there, it's very clear that we're not taking any parameters to this function. I think it's quite good. It's quite good practice to do so, because when you scan down the code, you can very quickly see that we're not expecting, or we're not going to be passed any parameters. So again, we can access these member variables, and any piece of code here can access them. So here we've declared the complex Z using the function, and then we're accessing them directly, z.re to dereference the real element of it, and z.im for the imaginary, and the assert sort of function, or I think it's actually a macro that expands, but anyway, it will check the condition in between the brackets, and if it isn't satisfied, then it will raise an error, and you can exit. So it's quite a good programming practice to use the asserts for things that you really want to ensure are valid. So as I said, in C, that would be fairly standard to us. We create struct, and then we access the elements of the struct, or what we'll refer to as member variables when we're discussing classes. Okay, let's have a bit more detail and a deeper look at how we create instances. So as it says here, inside the class definition, you should provide default values for member variables to ensure the elements are initialized, and as you'd expect, it's fairly standard. So there we can see in the struct again, we're just setting the real and imaginary member variables or elements to 0.0, and then we know that it's going to be in initialized state. So as we see in this test function, we've declared a complex Z, but we know that it's going to be set to 0. However, you might question why we put should there. Well, as I said, it's good practice for us to initialize the values whenever we create these objects. Therefore, we can't forget to do it. But you might not want to, and the reason is, well, when might you not want to set these default values? Well, perhaps your types act like the built-in types as possible, which is fine, but there may be a case where initializing the member variables incurs a significant runtime cost. It may be a complex, pardon the pun, but it may be a complex object that you're actually initializing inside the inside the object you've got here, and therefore we don't necessarily want to pay that price when we're initializing it. So as it says here, with the C++ 11 standard, we lose the ability to set the member variables just by providing the values. So we get no matching constructor. Well, GCC gives the error no matching constructor for the initialization of complex here. This is partly, unfortunately, what happens when the language is evolving. The languages continue to evolve, and sometimes certain new features and new standards can change the behavior. And this is one case here. However, as we'll see, that there are ways around this. So what we can do is we can control how we create the instances of our classes, and we use a thing called a constructor, kind of like functions, but within the type, and they have the same name as the type. So here we see the example here inside complex. We've got 3 actual constructors. We've got a default one, and then we've got one that takes 1 real parameter, and then one that takes 2 real parameters. And the key thing here is the default constructor doesn't need any arguments. And because we just want the compiler to generate it for us, we use that equals default. So as I said, they're not strictly functions, but they're very close to it. And why do we have to? The question might be, well, why do we actually have to explicitly provide the default constructor? Well, the language rules or language specifications say that if a user provides any constructors, the second 2 that are there, then the compiler will not create a default one unless asked to. So we are now asking it to do it. That's just the nature of the standard, and that's what we follow. So as I said, they're not they're like functions, but they're not directly callable. They don't return a value, and they can do initialization of member variables before the body begins execution. Okay, so if we look at the constructors where we just saw, you can see here the initialization that is being used. It's that colon and then RE brackets real that comes after the constructor signature, or the complex open brackets double real. So we'll call that effectively like the function signature or the constructor signature. And what's following that is a colon, and then we can put a list of the member variables, and here what we're doing is we're setting them to the value of the parameters that are being passed in the constructor. Now, it's good practice to try and do as much initialization as we possibly can here, because as I said, this happens before the body of the constructor begins the execution. As classes get more complex, it becomes quite important that certain things you can guarantee to have been set a value before you actually enter the body. So as I say, it's good practice to actually set as many of them here as you can. So here's a number of different ways we can create complex numbers. We can use the default initializer, as we see here, with 0. We can use a value with inside these braces, and as we see with complex, and then we're giving it the value of pi. And we can also, as mentioned before, because we've now got we've now got a constructor that takes 2 real values, we can now use the complex open brace 0, 1. Okay. Let's talk a bit more about member functions. As I said, inside a class, we've got member variables, which is our data, and we've got member functions. which are the operations or functions that we want to operate upon that data. It could do other things, but that's generally what we do with it. So here we see a quote from Wikipedia, where object-oriented programming, or OOP, is based on the concept of objects, which may contain data and code. That's just what I described there, the member variables and the member functions. And a feature of objects is that an object's procedures can access and often modify the data with which they are associated, which is exactly what I was just saying there. So that's one of the key things we want to know or be aware of. And we can pass these objects around, and they've got the context of the data and the functions that operates upon them. As I said, the bits of code are known as member functions. If it's a language like Java, you might be more familiar with referring to them as methods. So an example here in the main, again, I've put void in the as the parameters there to say that I'm not taking any arguments from the operating system. And you may have discussed in the previous lecture that there's a return 0 here, which is just basically saying everything's okay. And for main, you can actually not return it. You don't need to do a return 0. It'll automatically, the compiler automatically add that for you. But I think it's quite good practice to put it in. Then it's clear. And as I say, you can control what gets returned to the operating system when you call a C++ program by changing that return value. And there's a good number of them defined inside one of the C sort of standard header files. So in this example, which is more important, you can see here we're calling a method or a member function called size, and that's name.size. So we're asking name for its size, and that's because name has been declared or defined as a standard string, which is in the standard library, and it's a class, and so therefore has a set of methods, one of them being size. Now, to actually declare these so that we can use them, typically we declare them inside the class definition. So we quite often call this inline. So we can see here we've got the struct complex, and then we've got the constructor. So as before, it's just missing them just for brevity. But we've now got a member function called magnitude. Doesn't take any parameters, but it returns a double. And another key thing to take away from this is that we've got this example in a file called complex.hpp. Now, there's a number of standards or conventions really for extensions for the files, but generally if it's a header file, which was where we tend to put these declarations, it will be a .hpp file. And the body of our code tends to go in a .cpp file. There are other extensions, but that's generally the convention that we should use. Or they can be defined out of line. So just as I was mentioning there, we could define them in complex.cpp, which is the main body file as opposed to the header file, and the definition's the same, but here we use the actual scope resolution operator, the double colons there, to say that magnitude is being defined as part of complex. So we get complex : magnitude. And the thing about these functions, member functions, is that they can access the member data or another function just by giving the names. So we can see here that we're accessing the real and imaginary parts just by using the name. And this happens because the compiler puts in an implicit reference to the current instance for us. This is actually known as the this pointer, and we'll discuss this a bit more later. Now, when we're using it, we need to actually have an instance of the class to use. So an instance of a class is an object. So in that code there at the bottom, we've got complex Z, and we're initializing it with the values 3 and 4. that's giving us a complex object with the values 3 and 4, and then we're calling the magnitude method on it and comparing it to 5. Now, unfortunately, I can't see the question. Is somebody asking a question here?
Yeah, so the question is just to confirm that complex is the class and magnitude is the method.
That's absolutely correct. Complex is the class. As I said, the scope resolution operator sort of goes from left to right, and that's the double colons. So in the same way that complex is the class and magnitude is the method or member function, you can see below where we're using standard. That's kind of similar in the sense that we've got a namespace here called standard : and then we're calling a function square root. So it's a very similar mechanism as that. Another question there?
Yeah, so the question is there a difference between a struct and a class?
Yes, I'll come on to that. There is. I mean, cover it now. So basically, there isn't actually any difference between struct and classes in C++. The difference is the default privacy or accessibility of the member variables or functions within it. But we'll come to that in a minute. So, as I said, generally with classes, we can define new types to help us with our problem, help describe our problem a bit better, make it a bit more intuitive to us. For example, here the complex numbers, but we can have a set of operators an arithmetic operators that we can actually define for our struct or class. There's another question there. I'm sorry I can't see them, but is somebody going to ask?
Just you can keep going and have more methods in the same fashion.
Yes. All I was going to say here is the divide operation would be a slash. Now there are certain operators that we can't define, and dot being one of them. And these are listed on the Learn CPP on the CPP reference website. There's a good reference there which will give you this information. That's a really good site anyway, so you'll get more information on that. I'll just talk through how we do this. So what we call this is operator overloading. So in our struct, just as it was before, we just snipped that out for brevity. So imagine all the previous codes there. We're defining a plus equals operator. And what that's doing is going to increment the value of the current object and return it. I'll describe this in a little bit more because you can see the use of this point here. And then there's the other operator, which is the operator plus, which again basically adds two of them together, and this time it returns a new complex object. Now these are public, so you can access these operators on two objects. Sorry, there's a question there.
So the question is, CPP already has a plus equals operator, and this is overloading it. That's
absolutely right.
Or the new complex entity. Yeah.
Yes, absolutely. So yeah, so C++ got a set of operators like plus equals, plus, minus, etc. And the designer of C++, Björn Stroustrup, I don't know if I got his pronunciation of his name right. He's given us that capability. Really, the point here is that we can do a lot in C++ to allow us to extend the language, to add new types that have familiar operators to make, as I say, your code more readable. There's not just functions like this we can overload. We can overload things like when we want to maybe cast or coerce or transfer from one type to another. There's casting operators. There's a whole series of them. Again, I've pointed to the CPP reference because it's got a lovely list of them. And it's got a really good description of the ones you can define and the ones you can't, and the reason why not. So one of the things to take away from this is you'll notice here that we're using the const keyword and the ampersand, which, if we look at the plus equals, what we're saying here is we're taking a reference to a constant reference to a complex object, that being increment, and although we're going to use the reference to get the real and imaginary values, we're not changing it, and we're not able to change it because the compiler would raise an error if we try to modify those. So that's good, because in a sense we don't own that object necessarily, and so therefore we probably shouldn't be modifying it if literally all we want to do is get its real and imaginary values to basically add to the one we've got. I mentioned the this pointer, and this is one case where we do have to use it. Because we want to get the current. This is basically this pointer is the current instance, or that we're working with, and actually all member functions or methods are passed this, are pointed to this as their first parameter. It's hidden from you, but that's actually there. That's the first parameter of any member function, method, or in this case operator. And so that's why we get past that. So that would be the current object we're dealing with. Then we get past the increment object, which we're going to use the value of, and then we're going to return a reference to the new updated or pointer to the new updated object. Okay. Whereas the second example there is actually creating a brand new object and returning it. As I said, we can override the different arithmetic operators. So just as I was saying, the reason for doing it is so that we can write fairly natural syntax here, as we see with Z, where we're saying, well, Z, let's add the value in I to it, so that's the plus equals, and update Z. Or down at the bottom there, where we've got also C equals Z plus I. We can declare a new object C, which will be of type complex, and we're adding Z plus I there. So we're not updating Z. We're just adding Z to I and getting a new object, C, a new complex object C. So as the question was, well, okay, so what's the difference between a class and a struct? And as I said, well, technically the only difference is the accessibility. So what do we mean by the accessibility of the members? Well, it can be public, which is usable from any piece of code. So we use this to actually define the public interface of the class. And as I said, if you use struct, everything's public, unless we change the accessibility, which we'll see an example of in a minute. They can be private, and if they're private, they're only usable from within the context of the class. So in other words, something externally that wants to access the object can't either access that member variable or function as appropriate. So as we say here, it's really to allow us to create an implementation within the class that we can hide, encapsulate, and shouldn't really be of reference to code outside that uses it. And as I said, this is default for class. So if you, instead of using up here struct, you put class, then these methods would be private, which means you wouldn't be able to use them in this manner here. We need to make them public first, okay? And as we say, restricting the access to the implementation details is part of encapsulation. So the advantage of this is that we can change the internal representation of a class and we can provide the same public interface, or the methods, or the member functions that access that internal representation, and it wouldn't change the code that calls it. So that's why generally always being used for large systems, is because you can abstract over that complexity and hide the implementation. If somebody directly accesses the member variables like we are here, z.re, then if I change its type, or for whatever reason its name changes, then it would break this code here. Whereas if we had a method that said z dot real value, or get real value, then we could change the internal name or representation as long as it returned a real or a floating point number, and the method itself didn't change. So that's how we can manage change. So it's very useful. So the idea is that really generally you should make as much private as you can, unless it's a very basic type. I mean, from the point of view of a complex number, there's only these two member variables, or if you want to call them attributes, I guess. Then, and you can, they're not interrelated in any way per se in the class, and so therefore it's fine. For something like this, it makes sense. But if it was something much more complex, then you want to change the privacy. I just want to point out that there's also a protected keyword that changes the accessibility, and what that does is allow access to subclasses. So if we can inherit in C++, we can actually inherit from one class in another class. And if it was private, it wouldn't be able to see it. But if it's protected, then the subclass, the one that's new that we're using effectively, if you like, the base class, as we call it, the previous classes capabilities, then protected allows us to have that capability. So, and there are other relationships that are very useful. I would say that using those allows you to manage large systems, but you're starting to get quite advanced in how you're actually using the classes. For a lot of codes, you might just want to create a simple type like this and pass your data around, as a combined unit. Just to be clear, that the protected is also beneficial. Okay, so here's an example of a class where we've got called greeter, and we've got a string member variable, and we've also got say hello, which is a member function, and we're got a test here where we're taking a greeter object, and then we're applying that method, or we're applying the member function to say hello. Well, the problem with this is that we can't call that function, as I said, because it's private. So the way to fix this is we use the public access modifier. So if that's highlighting it, you can see it there. So anything that follows that public colon will be public, and in the case of a class, anything prior to it will be private. So in other words, another piece of code like test can't access g.greet here, but it can now access the say hello. So as I said, the benefit of this is it allows us to swap up parts of implementation without having to rewrite the client code. There's also, we can declare one class with another functional class as its friend, and that only allows us to access that bit of code and access to its private member variables. Now, you might wonder why we would have this friend relationship, which doesn't exist in something like Java, but actually what it does do is it allows us to have, say, classes that are collections, and they can do certain operations on the types of objects that are being placed in them. So the friend relationship, again, I would say is something that's reasonably advanced, but it is useful in situations where you want to allow certain a certain class to have access to another class to allow you to say manage it, as I say, as part of a collection. And this sort of controlled partial relaxation of encapsulation tends to make our system more isolated. It just, as I say, allows us to manage change much better, especially on a large system. At this point, if you're interested in designing object hierarchy, sorry, there's a question there.
Yes, so the question is, so basically private exposes to those functions stroke methods that have an implicit this in the signature to friends.
No. Oh,
yes, I'll have to think about this. And operator overloads don't have an implicit this, so need to be set to friend.
no.
I think we might have to make a record of this and reply for some.
So in this operator overloading we've got here, there is the implicit. As I said, anything in C++ that uses a class, or in this case a struct, it is confusing that structs are the same as classes, but the privacy is different. But everything that's like a function, like an operator here, has an implicit this parameter being passed into it. And the compiler also creates a reference for you so that you can access it. So I'm not quite sure what we mean, why we need the friend there. There isn't a friend, and there's no friend relationship here in this particular one. The friend relationship is between two separate classes. It's to allow, as I say, one class to access the internal representation of another one. And generally, you don't want to do it. Right? It's generally something you don't want to do because it's kind of breaking encapsulation, but for certain data structures like collections, you may want to do that. Does that help? Okay. So there was, what I was actually going to say was, with regards how you design object hierarchies, so in other words, a class that provides some functionality, then a subclass that adds more functionality. There are a set of sort of guidelines that that generally people apply, because it can create issues if you're not careful how you use this. And there's a good book. It's quite pricey, but there's a good book called Object-Oriented Design Heuristics by ARCHER2 that actually talks about how to use these access modifiers and just generally how you structure your classes. So if you get really into it and you want to create really quite complex hierarchies of classes, then I'd recommend that book. I can always stick a reference to that in the chat, or we can upload it later, just in case you're interested. As I said, the book's quite pricey, but it is a good book for explaining why you should do certain things and why you shouldn't, especially around what you do with, as I say, with object design. I think there's another couple of questions there. Sorry, Kevin, is there anything that's jumped out?
No, I'm just trying to write an answer to the previous one.
Right, okay. So in the examples there, we saw the reference to the ampersand for references, and also the use of the const keyword. So let's have a little look at constants in C++, because they are important. So variables are what was sometimes referred to as objects, but not instances of classes, but just variables here, can be marked or qualified with the const keyword. And as it says here, objects, and what we're meaning here is integers, real floating point numbers, etc. They cannot be modified. Sorry, is there a question there that's sort of related to this?
No, that was me. No.
Okay, sorry. I really wish I could see that chat screen, but unfortunately I can't at the moment. So the compiler will give you an error if you try, which is great, because there's certain things we don't want to modify. So here, in this example, we've got, we're declaring I as a constant here and giving it the value 42. And then we can reference that. We can pass it to the standard cout and see its value, which will print 42. But we can't increment it, so we can't use the plus equals on it. So we'll get an error along the lines of cannot assign to variable I with const qualified const int. So wherever possible, you should be adding to const to your local variables. What's your question?
Me again.
All right, sorry. You can just call out over me when I'm quiet if there's a question then. So as it says here, since function parameters are just local variables, they're effectively, yes, local variables on the stack. They can be const too. And as we saw earlier there, we've got complex const A and we've got complex const B in this operator minus. And we've marked them a const because there's no need for us to modify the values, as I mentioned earlier. So really we should mark them as const. And in this case, what's actually happening is that when we're calling minus, we're actually taking a copy of the complex number that's being passed in. So A is a copy of whatever complex object we're passing there, and const B, the complex B, is also a copy. And we're returning a new value, a new complex object when we're doing the arithmetic. As mentioned earlier, member functions or methods have an implicit argument of the instance they belong to. So that's the object. So the object, as I said, is an instance of a class. And if they don't need to change an instance, then we should mark them as const, as we have here. So that's why we marked the magnitude member function or method as const. So it returns us the magnitude of the complex number, hence the double there, but it doesn't modify the complex number itself, so we mark it as const. Now, we can mark variables as being constants using either of the syntaxes here. We can say const int I equals 42, or we can say int const I equals 42. And you know, the rule for the one on the left here says that we apply const to what is on the left, unless there's nothing on its left, then it applies to what's on the right. Whereas on the other side, we always put the const on the right of what it modifies. Now it says it doesn't really matter as long as you're consistent, and I think that's important. I think you want to be consistent when you're using it. But I think int const I is a little more logical. So for example, in C, although we're not going to talk about pointers here, we'll talk about references instead. But in C, that if we had a pointer to an int, it would be int star I equals 42 if that was an integer, a pointer to an int. So it seems more logical to put the modifier of the type on the right hand side of it. So in other words, if we've got a constant int, it should be int const I. A lot of old code will have the former, the one on the left, and some older programmers like I am might tend to use that, but that's just historical. But as I said, I think the right hand side's more is more logical nowadays. Okay, as I said, we're going to talk about references because they are really key in C++, and they're really important to how we manage our objects and our memory. So as I said, in the early examples, where we didn't use a reference, we were getting a copy. So here, just with a double, if it's a double variable, as it says here, copy equals original, then we get a new value, and it's a copy. And it's exactly the same if we pass it into a function, as I mentioned. So advance one time step here is getting past sim state old, but actually we're getting a copy of old. So one of the things to think about here is it's up to the programmer to decide when things are copied and when we might pass a reference. If you're doing some complex simulation, say like computational fluid dynamics, in this example here, current state may be large, and if we're copying it when we're passing it into advanced one time step, it could be expensive in terms of runtime and memory to copy it. So we don't necessarily want to really be copying all the data every time we either call a method or a member function or just a standard function. So that's why we want to consider how we can optimize how we pass data around. And we do this with a reference. So it's effectively a name that aliases an existing object. It has to be initialized, and it can't be rebound to a new object, unlike a pointer. So if we look at the two functions here, we're passing a double scale, and then this the next parameter is basically a reference to a vector of doubles that that type's defined in the standard library. So that's the standard : vector, angle bracket double, then right angle bracket, an ampersand, and the actual reference we're passing is named X. Sometimes I think in C++ it's a little bit confusing, and I might sometimes refer to it as word salad. Sometimes it's a little bit difficult because there seems to be a lot of symbols going on here. But actually, when you break it down, it's actually quite straightforward. The ampersand is a reference to something. The angle brackets that you're seeing here are basically saying, it's a bit like a template, and we're saying create me a vector of doubles being a floating point type. Yeah. And once you see a reasonable amount of that code, you get quite used to it. So basically, to create the reference, we use the ampersand, as I said, and we put it after the type and before the variable name. So that's why I'm after that right angle bracket and before the X. So when I said it was must be initialized, you can't just declare a reference variable without initializing it. It has to. The reference has to effectively reference something. It can't be like an empty reference. And when we use it, as I said, we're not copying it. So in this case, scale vector gets past the reference to that vector and doesn't copy it. So in the test function, we've declared a vector of doubles using read large file function, which returns us one of those and puts it into data. And then when we call the scale vector function, we pass it -1.0, which is the scale, and then we pass data, but we're passing a reference to data. So we're no longer copying that large file data, we're just passing in the reference to it, so that we're not copying it. So it's quite a bit more efficient to do that. And as I said, we can qualify a reference as const. So in this case, we've got a advanced one time step. It's taking the simulation state or sim state, and it's const ampersand, so therefore it's a constant reference. So old is a constant reference, which means we can't modify it. And we should try to pass as many constant references as we can. In other words, what I mean by that is, if we know we're not going to update it, then we should make sure it's a constant reference. And the compiler will get an error if we try to change it, or if we try to call another function that could change it. So not only can functions take references, they can also return a reference. And in this example, we've got a class called AtomList. As I mentioned before, everything before that public colon keyword there is private. So that's in what we quite often refer to as the internal representation of a class. And then what follows it is public, so it can be accessed outside. And what we're actually making public is a member function or method called getCharge. The void in bracket means we're not taking any parameters, but we're returning, and this, as I said, sometimes in C++ makes things quite difficult, but what we're actually returning is a constant reference to a standard vector of doubles, okay? And on the right-hand side of the function protocol signature, the getCharge, open brackets, void, close bracket, the const there is saying we're not modifying the internal representation of AtomList, and we're returning charge, okay? Is there anything anybody wants to ask at this point on this? Cool. So as mentioned earlier, just another point there, we're returning that charge or a reference to that charge member variable. Now, because we're returning a const reference, the function that calls it, so analyze underscore MD data there below, calls the atoms.getCharge method, and it returns a reference to it. And we can see that that's been, we've got the reference is called charges, and we're setting it up as a constant reference. But charges can't change it. Although charges, so when we call a method on charges, we can call certain methods. We can't actually change the internal representation of it because it's const, so we can't change what's in that reference, and that's another benefit. So we can decide to effectively pass a reference to our internal representation for efficiency reasons, and we can pass it back as a constant reference, knowing that we're safe, that the calling function or piece of code that somebody else might be using isn't going to update it and modify it without maybe calling another method or member function that we've declared to do that. So we can control not just access to the data, we can control how the data is actually used, and that allows us, as I say, to create protection. So we can allow people to get the reference for efficiency, but they're not necessarily able, if we don't want them to be able to update it. So they can use it but not update it, and that's pretty powerful. And returning references is very common, and we use that a lot for container classes. Okay, so we can declare references using auto, and we give sort of 3 examples of how to use it. So if we said auto x and then equals some function call, let's say, then that would mean we've got a modifiable copy, because as I said, it's not reference, so we get a copy. If we use auto ampersand x, then we'll get a reference to the other object, and as it says here, we'll get the same constness as the initializer, or what would be on the other side of the equals. And that means if it was const, it'll be const, and if it's not const, it's not const. So we don't need to define it. It just means that we'll automatically get the constness when based on whatever the initializer is, for example, a function. And then the last one here is we can use autoconst ampersand x equals some initializer when we want a reference to the original item and we know we're not going to modify it. And as you might expect from what I've been saying, we prefer to use autoconst references whenever possible to ensure that we're not modifying data that we don't need to. Now, it's not a mistake. The double ampersand in the second one is correct. It's called a forwarding reference. So one of the things we would call if you like, a non-const reference is we call it mutable. It's a mutable reference. And so if something is mutable, then we can change it. Otherwise, it's constant. Is there anything there anybody wants to ask some questions around? Because it's quite, I think this is quite subtle. No? Okay, well, one of the things I will say is you might think that getting returned a constant reference, that's fine, but actually you may find that your code isn't quite, you can't just get rid of that constness once it's been set for you. So just you know, keep that in mind. It's actually pretty robust with regards. The compiler is pretty robust in ensuring that you don't modify a const or a mutable object. Okay, let's have a look at some compilation. So, as it says here, C++ distinguishes between declaration and definition. So a declaration tells the compiler that the name exists, what kind of entity it is, and its type. You know, and a lot of the time, this is all the compiler actually needs. And declarations can be repeated as long as they match exactly. So that's a key point. A definition tells the compiler everything it needs to create something in its entirety. It's also effectively a declaration, but the one definition rule says that definitions must not be repeated. There is an exception, but the definition should not be repeated. The exception to that rule is actually templates and inline functions, but I'm not going to discuss that in more detail today. Okay, so as I sort of mentioned earlier, well, okay, so what does this all mean, and you know, where do I put my declarations and my definitions? So we generally put our declarations of functions, definitions of classes, and that includes structs, and global constants in our header files. And as I said, there are common suffixes. They're, as I say, it's convention. So .hpp or .h or .H. But as .h is generally used for C, if you're writing C++, I would recommend you use something like .hpp. And the definitions of most the functions, or as you saw, when we're doing an out-of-line member function or method declaration, then they go in the what I was calling the body file, but the implementation file. And the common suffix for those are .cpp, .cxx, .cc, or .C. Again, my preference is .cpp, but you may find people use the other alternatives there. And headers can be, this hash include basically brings them into the scope of another file. And if we need to use, say we've got a file, say we've created some classes or some structs and we want to use them in another piece of code, then we use the hash include statement to include them. So here's an example. So when we were defining our complex number struct or class, we would put it in a complex.hpp file. And as you can see here, we've actually decided that we're going to make the real and imaginary member variables private here. And we've got the declaration of the operator there as well. So we put them inside the HPP file. Now, one of the things that may jump out, if you're used to C, then you'll recognize the hash if and def statements here in blue. These are effectively done by the macro preprocessor, and it's actually quite useful. It's quite key that you actually use what we call a guard statement, and that's what these are. So basically what's happening here is the compiler is looking to see if the value uppercase complex underscore HPP is defined, and if it's not defined it, then it defines it. Okay, it's defined it with no value, but it is now defined, and this text that follows it before the hash endif is then returned, if you like. So if this was, if we were including this file, if complex.hpp underscore HPP wasn't defined, then the compiler would load that in and effectively, if you like, paste that code from struct complex down to the // etc, if you like, into the file that you were including it into. However, because it also defines the variable, it means then if we were to try and include it again, because you could include the file multiple times if you wanted it in your implementation file or your CPP file, it would only do it once, because there isn't an else in there, so nothing else would be returned if the variable is declared, if the macro variable is declared or defined, and so therefore you get nothing. Now you might say, well, okay, so what's big deal? What's the issue there? Well, we can't have multiple definitions of struct, so that prevents it, and that's the way C and C++ manage that, by basically we use this macro variable. And the convention is for the file complex.hpp, we use uppercase complex underscore HPP. And as I said, it's known as the guard idiom, and it's there to stop us getting compiler errors when if we try to include the file multiple times. Okay. Now there's an exercise. I'm just looking at time. We've probably got some time. Are there any questions that people would like me to answer or go through in a bit more detail? I'm happy to whiz back through the slides and try and provide a bit more detail.
So there's a question, someone is not clear on the use of this if-endif hash, if-endif.
Yes, I can understand that. It's slightly confusing. So if we wanted to use this complex type in another piece of code, we need to know something about it. Yeah. And the way we can find out something about it is to include the complex.hpp. So in other words, in our code, we would have a hash include, open quotes, complex.hpp, close quotes. And the C++ compiler would then load that file in line into our, what was likely to be a CPP file. And basically, as I said, paste this code into your code at that point. And then it means you can reference it, because it's as if you've typed it yourself. Yeah. So what we don't want is we don't want this bit here, struct complex, twice in our code, right? And it's possible we might have an include file of an include file, and each one of those include files actually includes complex.hpp. They both use it, right? And what would happen there is you get include file, including another include file, including another include file, and you find you get 2 copies of complex.hpp in your final CPP file. And then what would happen there is you'd have more than one copy of complex, and the compiler would complain, and you wouldn't be able to compile your code, which would be really rather annoying. So the way we get around it is this hash define here, this bit here says, okay, is this macro variable? Because this is anything with a hash on it is a macro language that sits in the preprocessor to the C code. And this is from C. So in C or C++, there's a thing called a macro preprocessor, and it runs before the compiler actually compiles your code. So before the compiler actually decides to do anything about looking at struct complex, etc., it does a parse through your code, and it looks for statements a bit like this, which are to do with the macro language, okay? That's built into C and C++. And then it does these operations first, and then, it, dependent on what happens, it will then go and compile your code. So in the macro preprocessor, as I said, if we haven't defined this variable, macro variable, complex_hpp, that's what this if n def means, it's if not defined, then whatever follows at the end of that line, the next thing will execute. So everything that's from this if n def to this end if will be output if it's not declared. Yeah. So if complex_hpp isn't declared, then all of this is effectively processed, and in the case of an include file in your main implementation file, your CPP file, it's actually, if you like, cut and paste it. But because the first line of it defines that variable, so this hash define now says, yes, I've got it. I'm now saying this is now defined. This now doesn't have a value here, but it's defined. So this in another include file, if it was to include complex.hpp, this would fail. So in other words, this would no longer be not defined, because in the macro preprocessor, we've already processed this file once, and so therefore this must be defined. Therefore, the second time we come across this bit of code, yeah, we do nothing. And therefore, that means that none of this is then output into your code again. And so therefore you won't get a compiler error because you only get one copy. What basically this does is ensures you only ever get one copy of whatever is in between, the hash if ndef and the ndef. And the reason why you need to do it, or you should consider doing it, is, as I said, you may have quite a complex system, and it may have multiple files that use the struct and want to reference it. So therefore, multiple files may need to include complex.hpp, yeah? And if we don't put the guard in, you might find that we get multiple copies loaded into one of your files, and that would then not compile. Does that help? Does that make it any clearer? Basically, until the latest version of C++, we don't have proper modules in C++. What we have is the opportunity, or the ability to use hash include, and it's really just a macro expansion. It literally is just saying, I'm going to expand this text, and the way to get round the issue is for us to use this guard statement. Sorry, Kevin, did that answer it, do you think?
Yes, thank you. I should add, you'll see this all over the place. You'll see this all.
Yeah, you will. In large systems, you'll see it everywhere. You'll see it in a lot of C code as well, for the same reason, because it's the same macro preprocessor that's running in C or C++. Is there anything else people want me to cover? Anything around references or the overloading?
Okay, here's another question. What is the advantage of having to write methods to access private variables instead of accessing it via structs in a straightforward manner? Isn't the second one more readable?
Well, for a very simple type like the complex number we have, yeah, I would argue that, you know, a complex number we know has a real element and an imaginary element, and their floating point. So therefore, I would kind of argue that you just make them a struct and you just access them directly. And actually, I think in one of the later C standards, it's got a complex type defined now anyway, and it's just a struct effectively. So for a simple type, I think you know, and we've done this is artificial in a sense because we want to give you an example, but for a simple type like complex, which we, you know, that's what it's always going to be, then I think that's fine. Where you've got something that's more complex, then really I'm sorry, that's a bit of a pun, but for something that's more sophisticated, then you should really try and make your data private and a set of public methods to access it for the reasons I mentioned. Is that supposing we could start out in a more sophisticated, I'm trying not to use the word complex, in a more sophisticated class, we may, for example, you know, originally define it as a real number using a double here, but actually we might decide later that actually we want another class here, another object, another instance of a class, because there's more we want to do with it. Now it might be that we get the double value out of that, you know, embedded class or object there. But and if we wrote methods around it, then probably the public interface that people are using in their code wouldn't change. But we've changed it internally, and we're able to make that change. And knowing that any change we make to our internal representation, by internal representation, I'm talking about this bit here I've highlighted in complex, you know, the two member variables, wouldn't affect anybody else. So that's the reason for doing it. You know, generally, if you've got something that's sophisticated, I don't want to use the word complex, but something that's sophisticated, then you should really be writing methods to access it, which becomes your API, you know, your application programming interface. And by doing that, it allows us to replace something here with a more complex version of it. Oh, I'll just use the complex word again, sorry. But does that make sense?
Yep.
Cool. Anything else?
Yes, there's another question here. Could you explain the double const example again?
Yes. So this one here, I think so. So when we're using auto ampersand x here, what we're saying is we're not concerned with what the initializer is going to return us as a reference. So in other words, if you've got, so say it'd be easier if this said auto ampersand x equals some function name, yeah? Well, if that some function name returned us a mutable reference, then that's fine. That definition we've got there, or that declaration rather that we've got there, would be fine. If some function returned us a const reference, then that would also be fine. It would compile because it can manage both. It basically says, let the compiler deduce and what the constant is based on what the initializer is. Yeah. So if you don't know, then that's the best one to use. However, if you know that you're never going to modify what's in the reference you're getting back, you're just going to effectively read it, you're not going to update it, then it's preferable you use the const ampersand x. You know, example here, the const ampersand reference, because then it means that you can't modify it. All this basically is saying is that not only will auto work out what type of x based on the initializer, but whatever reference I'm getting back, whether it's const or mutable, I don't really mind. you know, just give me what it is, and I'll obey it. If you understand, does that help? I know it's a bit confusing. And was that the example you were asking me for?
Oh, yes, yes.
Cool. Okay, how are we doing for time? So there's an exercise here, and you could go ahead and do it now, or maybe you want to do it later. And just checking, did everybody manage to get themselves set up with a compiler or access? I think we're running an Archer, aren't we, Kevin?
No, I think it's just laptops or Cirrus, perhaps.
Is it just laptop?
I think everybody's okay. Yes, in the basic.
Everybody's okay. Yeah, because last week we were running on Archer if you didn't have a setup. I know normally we run on Cirrus, but last week it was Archer. Or not last week, the week before. I know it's quite a lot to cover there, and you know I do tend to refer to things like this in C++ as word salad. I think they're, you know, when you first look at it, it's kind of quite confusing as to what's going on there. But actually, if you break it down, I think it's quite straightforward once you get used to it. Anything else?
Shouldn't it be more like punctuation salad? Shouldn't it be?
Yes, symbol salad, maybe.
Symbol salad. There's another question here in the chat, which I think I'm going to write down, and will supply you with a written answer tomorrow.
Yes.
I think it takes us a while to pass the question.
Yes, it's a good question there. A beginner-friendly C++ book. The Strauss book is too large. I think you'll find all C++ books are too large, he said jokingly. The CPP reference site is pretty good. There's a number of C++ in 24 hours books that kind of help. So there's a series, I can't remember the publisher, but you learn C++ in 24 hours or learn C++ in 7 days. Some of those are actually reasonably good to get an overview of the language. Does that help? I'll just check. I think it was this previous session this afternoon that possibly went through the book list, and there's the effective C++ book. Now, whilst that won't teach you C++, it's very good for understanding some of the gotchas you might come across. So that's quite a good book. I recommend that one if you're going to do a lot of C++. You got it. Good. Yeah. I'm just trying to remember the name of. There's a little C++ book. It's not too expensive. That's quite good. I'm just looking it up now. I tell you what to do. We can send it out. I'll look it up and we'll send it out. There's quite a nice little book that's got an index and some of the STL, the standard template library references in it, just the key ones, and it gives quite a good explanation of how everything hangs together. For the life of me, it just slipped my mind, but we can send that out. And it's, as I say, it's not that expensive. Okay. There we go. Yeah, some of the books are, as it says there, are out of date with the language moving forward. For example, there's C++ in 1 hour a day. There's the SAMS book that covers C++ 20. It's not a bad book. It's quite big, but it's about £30. And as you say, some of the good sort of cheaper books are a little bit out of date. But yeah, that's C++, the SAMS book, C++ in 1 hour a day is not bad. And it does go into, as I say, C++ 20, so you get some of the new capabilities. Okay, if there aren't any other questions, then I think that's us finished for the day.